Now that we've completed our 3D plant layout, we need to convey this information over to a 2D drawing. With Solid Edge, you have immediate drawing creation while at the part or assembly level, so creating automatic drawings is simple. What we're using here is Solid Edge's Quick Sheet templates. Quick Sheet templates allow for super fast drawing creation, as many of these standard items are predefined and only need to know the model file. A handy preview shows us the general look of the drawing, so choosing the right one isn't just by the file name. As I'm speaking, Solid Edge is computing all of the visible and hidden edges of the drawing views. We'll be placing 5 views: a top, 3 section views, and a detail view. Once the edges are determined, Solid Edge will apply the appropriate line symbology to them. It's not uncommon to have hidden lines dashed or even drawn in red. For this demo, we display the visible edges slightly thicker to better show the key elements. Quick Sheets, as you can see, are quick and complete, but sometimes you need to add additional views. Solid Edge lets you add new views from existing views or views from other models. We'll create an isometric drawing view of this plant. Isometric drawing views generally don't require the view detail, and Solid Edge lets you tweak the drawing view quality, gaining added performance. You can still add dimensions later. As handy as isometric views are, you can make them more appealing by shading them. Solid Edge supports many display types that will surely fit your needs. In a matter of seconds, we'll have an ISO view that looks as it would in production. As you can see, our drawing template has a complete set of layers. Not only can layers control dimensions, notes, etc., Solid Edge allows you to control drawing views to be placed on a layer as well. This helps us maintain large assembly drawings by only turning on the information we need to work with. All I have to do is double-click on a layer to activate it. And with this template, the predefined drawing view also turns on. I can also use window commands like right mouse button click to set the views options for a layer, like turning them on and off. By having only the views that I need on the screen, we can easily use the radial menu to pan and zoom around the drawing with ease. Large assembly drawings tend to have slightly different requirements than drawings of parts. Because of the amount of data, section views can be difficult to understand. Solid Edge allows the user to set the drawing view depth of a view. While you can set the depth to any location, Solid Edge allows precise inputs and is handy if you need to know what the cross-section looks like 10 meters down the assembly line. While the drawing view updated, the results can be valuable in seeing clearances between machines or seeing how much working space an employee has. Again, accomplishing this in 2D would be nearly impossible. Let's show you some of the powerful tools that Solid Edge provides to aid you in conveying how much clearance there is between the machines and the workspace in this area. As we did earlier in the demonstration, we can use a block to indicate a center line in our drawing. We'll use the Smart Dimension tool to determine the distance between the edge of the wall and the center of our conveyor. We can also specify the width of the conveyor and also the height. Smart balloons can be added independent of parts lists to better identify specific components. By adding more control points, we can stylize the look of our balloons. Changes made to the properties of that part will update automatically in the balloon text. While this sounds simple, tools like this are important in documenting large assembly drawings. Let's move to another view by simply double-clicking on the section CC view. Adding center lines and placing common text from our block library speeds up the process. Solid Edge provides tools to create and store blocks inside of the drawing file. We've taken a look at dimensioning with Smart Dimension. Now let's look at point-to-point dimensioning. When using this dimensioning tool, Solid Edge provides great feedback to the user as to what type of dimensions you want to create. Does the user want to create a chain or stack dimension? And in this case, we're going to use the stack dimension. Here we're showing the height of the conveyor and the height of the piping. Once again, we'll create the dimension from the edge of the wall to the center of the conveyor. You can change the position of the dimensions by simply clicking on the dimension line and dragging it down. You can also change the position of the text within the dimension. Once again, we can use the balloon command to help convey what items are being used in this area of the plant. We also need to get information about the piping and fittings used in this area of the plant as well. Large assembly drawings tend to be large in both part count and physical size. Nothing is more unproductive than having to zoom and fit repeatedly when placing dimensions across the model. Here we're going to zoom into the top view of the plant layout. Once again, I'm going to use the distance between dimension to start dimensioning different sections of the conveyor. In this case, I'm creating a chain dimension. Watch as we detail this portion of the top view with our Smart Dimension Distance tool. Whether it's stacked or chain dimensions, Solid Edge automatically stacks them in the right spot even if the view is off the screen. Solid Edge is the leader in drawing creation with years of proven experience. Large assemblies typically don't have parts lists due to the size, but adding balloons is still very useful in communicating what's what. Included in Solid Edge are handy tools to align balloons, thus improving the overall representation of the drawing. Even though we're working on a lightweight information, we can provide full detail information about the placement of the objects. Simply put, the lighter the view, the faster the performance, but usability can't be sacrificed. Solid Edge has found this delicate balance. Now let's move to the final section view. Large assembly drawings typically are used to communicate positional information, hence full component details aren't needed. The detail we are working with is the draft quality view, meaning that it is very lightweight. Solid Edge understands this, and with our draft quality views, huge performance gains are seen, but full dimension support is still available. Once again, we need to convey where the center line is for each of the conveyors. By using the same centerline tool as before, remember that Solid Edge gives the user the tools they need when they need them, like finding the midpoint of a line by hitting the M on the keyboard.